Yeah, so it's 11 after. Like I said, if any of this prompts your um prompt ideas and you want to contribute, just jot your name down at the end of the list and we'll go to you after we get through these and we'll do until roughly 10 minutes to the top of the hour, going around the room. And appreciate not taking up too much time in each of these, but we do have a chunk of time, and I think six or eight folks are in line. So looking forward to hearing what people have. So take it away, Ruth.
Okay. So I'm coming from the Sustainable Data Management Cluster, which just finished a paper about the CARE principles and what repositories should do if they're trying to be more, quote, caring. And for those who don't know what the CARE principles are, they're basically principles for Indigenous data governance. Next slide, please. Um, and so what I'm going to briefly do is just talk about, what the CARE paper results were, what a main takeaway was from the paper, and then talk about the things the group is next doing, which is about caring metadata. Next slide. And so the whole point of the CARE principles is that if you're dealing with data about indigenous peoples, lands, anything really, the issue is you want to have collective benefit for those people. They want to have some authority to control access to that data, for example, that you have a responsibility and to be ethical about the way you deal with that data. So next slide. And so the CARE paper results, it's really just what a repository should do if they are dealing with Indigenous data and people. And one of the main outputs is basically a list of activities that repositories should do, and they're categorized by sort of the kinds of activities that happen in a repository. There's a actual poster-sized version of this repository activities involving Indigenous data and people at that tiny URL. If you have trouble accessing it, let me know and I can get you access. Next slide. And basically what we did was we took the CARE principles and mapped them to repository activities in the areas of situational awareness, outreach, protocols, and technology, basically. And it's a pretty messy diagram, but there's also a full-size version of this, poster-sized version of this that you can also get at that tiny URL. Next slide. And one of our reviewers kind of summarized the discussion in our paper this way. And so these are basically snippets of his summary that I thought were very interesting. Um, and so I'm including them here. I think I know who this might have been, but I don't know for sure. So, I can't really credit it to that person, but they are quotes, so I put quotes around them. Um, and the issues are that Indigenous people care about data about their lands, and that includes any and all kinds of data, including even satellite data. And but that doesn't mean that they necessarily want to have sovereignty over all of it. It may just mean that they need to have access in ways that work for them. And that if you are having that kind of data, which practically any ESIP data provider probably does, then any of the decisions and guidelines about that access and control should be made in collaboration with those people. And the problem with that, of course, is that they get overloaded. And so therefore there needs to be ways for repositories as groups to work with other groups of indigenous peoples to sort of work that out and minimize effort on both sides, basically. And basically that repositories need to develop clear policies about who's responsible for the data, what to do if there are conflicts, and if there are issues where you need to take data down, for example, how to do that. And I note that while the paper was really long, um, there's a lot more work that needs to be done in this space. And so I think that's one of the reasons why I thought it was worthwhile putting in here, because this is all an interoperability issue, obviously. Issues of access and control and that sort of thing. Next slide. And the next work of the Sustainable Management Cluster is on the concept of, well, what can we do to beef up the metadata that we have to make all of this clear to users and to the indigenous peoples that that this is all about. And so I note that there is a session this Thursday at bright and early time to review the metadata for 3 volunteer data sets and to consider existing metadata standards and do they need to be updated, etc. Next slide. And I think that's it. Yes. And so that's information about the cluster itself, if you want to join. I suspect that at some point this might actually make a good INT kind of discussion or talk. And that's it for me.
Yeah.
Any questions?
Thank you, Ruth. Can you drop links to the tiny URLs in the notes doc?
Sure.
I'm realizing if I'm sharing, I can't copy paste stuff into that doc. So
okay, I'll go find it. And
I want to capture. I guess I want to capture those, and then in general, I guess if folks can jot down, like we've just suggested, maybe this this report would be a good ITNI. If folks could jot down a few more specifics about these ideas that we provide, I would appreciate it. Sherry, for sure, and if others have ideas, please jot them down. I meant to be taking notes, now I'm sharing screen. I didn't really know that, so. But thank you, Ruth.
Can you change the screen share so it's just the display and not the things at the top of the user people?
I could try. Or do you know how to do that with Zoom? I'm not a Zoom native, so.
It's helpful. It won't be that display. He's changing that one to get that there. Oh, maybe you are sharing.
So that one is projecting, and I'm sharing my screen into Zoom. All right, who is? Yeah, here you go. These links are pretty spot on, actually.
Yeah, Ruth will fix it if I'm not clear. Oh, you all can hear me too.
And you're in Concept Shorts?
Yes. Hopefully. Okay, so I'm John Graviel. I'm a longtime semantic and metadata person. And but there are actually 3 presentations in here. The first is very short, and the second 2, Brendan and I have been collaborating on. I'll talk about one, he'll talk about the other. This is just, this first item is just a tip that I'm promoting for something that I've developed and I found really useful. If you're a person who likes to work with vocabularies and would like to be able to make them into semantic resources that can be put into a semantic repository, and you don't really want to learn all of core and SCOS in order to do that, then there's actually a way you can be a pretty good vocabulary builder with just an Excel spreadsheet and a process. Next slide. So it's called Excel to RDF. There are actually, I think, maybe 3 or 4 or 100 Excel to RDFs now on the web. This is the one that's at excel-to-rdf.readthedocs.io. And it uses GitHub, and it uses Cosplay, which is a very nice tool in and of itself. It uses Google Sheets or Excel, either one, depending on which workflow you choose it. And then you can pick the repository of your choice. Bioportal or something compatible is nice because it can automatically read in the ontology off of GitHub whenever it changes, which saves you one step in managing it all. I'm not going to go into the details of the process because time and all, and only a third of you would care. But Excel to rdf.readthedocs.io is really a fairly cool process. Next slide. So Brandon and Ruth and I are all highly motivated around many things with data science, particularly about metadata and vocabularies. And there's the thing that I'll talk about next slide is our presentation, our training that happens in about 2 hours and a half on the community ontology repository, which is a place you can put your vocabularies and ontologies that you just created using the cool pipeline I just discussed. And it's really intended for any Earth or space science ontology or vocabulary. And we hope to populate it with a number of the more important ones. But the ESIP core, as we call it, Community Ontology Repository, is dedicated especially to help ESIP and the community use it. So you can come to that training and learn a lot more about it and how to engage. Next slide. There's training hands-on if you want it to be hands-on. And last third is discussions about where do we go from here and how do we make this really successful ESIP resource. Next slide. So it is, our goal is, of course, to fix the problem. Instead of fixing the problem with metadata, we're fixing the problem with vocabularies. And this is the place that can help fix it. Next slide. And this slide and the next one is just to show that this thing really exists and really does have vocabularies in it. Go ahead to the next. And we can create ontologies for anything we want and put them in there within any reason. So next slide, make you feel right. That's what a real vocabulary looks like, you know, an adult's vocabulary. Maybe not exactly, but you get the idea. Okay, next slide. Oh, yeah, did I say they're tchotchkes? Okay, that's all I need to say about that. We do hope to encourage the leadership of both ESIP and all the funding agencies as a part of this meetings process. We'll see how that goes. Sorry, there's always one more than I thought there was. I think that's the last slide. Yes.
Okay, thanks, John. Do you want to stop for questions or should we just keep rolling? Okay.
You can ask.
Fair enough. All right, so I'm Brandon Whitehead, and I just wanted to say quickly that I slightly missed the brief. I thought we were providing context for our sessions, but I can answer both questions.
You are. That was the intent.
Okay, fair enough.
Yeah.
Okay.
A little bit of both was the intent.
All right. So
carry on.
The session that I'm running on Friday, I'm really interested in the mess of semantic models that are available, that we create and that are available in this everywhere. And my session is about sort of my view, and there's a few of us. We're going to talk about some of the our experiences in uplifting different resources and some of the problems that occur along the way. And also, it's sort of my view, my own personal experience about how you work with several vocabularies. When am I going to the next slide, please? And the next one. So and just as an example, and I'm using these three purposefully, right? So the USGS thesaurus, for any of you that may not know, it has on the order of 1,000 terms in it, and it's meant to index or be used against the science base as well as some other data products. All right, and then quite similarly on the NASA side, the GCMD, the Global Change Management Directory, science keywords have been around for ages. In just the science keyword section, there's approximately, what, 3,600 terms in there, all right? But what I find interesting is, if you would hit the next one, please, that NASA also has what they call the NASA thesaurus, but I call the NASA STI thesaurus to try and eliminate some confusion. But that one's been around, I think, even longer, and it has on the order of 18,000, so 18,500 terms, right? Now, and that index is, as I understand it, it's I think it's NSTR, it's something with a technical innovation repository documents or something like that. So each one of these three are thesauri, right? Sort of notionally, and they have a purpose, right? They're meant to index content and help with search and retrieval. If you want to hit the next one, please, Dave. What I find interesting is there's an overlap. Okay, so it's on the order of a couple hundred terms right now. Now this is devoid of any context or any domain linkage, but sort of my overarching question is, even with the promise of the semantic web, we're still just in different stovepipes. And why is that? Is there space to collaborate? Or is there a community of practice, perhaps at least a cluster, where we could have a chat about how we build an interoperable or maybe a core set of terms that we can all agree are going to be used in a certain way, and then build off of that for our own, the specialized things like, for example, GCMD has platforms and some other stuff that would only be relevant to that set, like to NASA in that particular section, right? Okay, so that's one of the things that I'm interested in. If you don't mind, go to the next one. And this is an example that you probably can't read, and that's probably good. But the center is a single concept, okay, or phrase. It's sequence stratigraphy. And each one of the colored entities is a unique URI or IRI, a unique identifier to the concept of sequence stratigraphy. And then some of the other linkages in there are to the definitions. If you happen to stumble on a copy of this where you can actually read the definitions, they're quite similar, okay? Some of them are the exact same, like it was copy and paste. And I won't tell you which one it is, but I will tell you that these are all from the same vocabulary. Okay? So these are the questions I have and the issue that I'm trying to highlight, and the conversation I would like to start having.
Here.
And should I drop the mic?
Perfect.
Oh, sorry. Sorry. This is just me picking my session. So it's Friday at 9 if you want to have a chat. But those are the types of questions I'm interested in. I think is it okay we do questions, John?
You have one question. Yeah, take the mic.
Yeah, go for it.
So about the core, the community ontology repository, I heard two things that made my eyebrows raise a little bit. One, there's an implication that anybody should just sit down with this spreadsheet, or could, right, and create a vocabulary. Is it your position that there's no skill involved other than spreadsheet skills? Or, that's my first question. And my second question is, are you not worried about actually promoting exactly what Brandon is trying to get away from with that core? And I guess I have a third question. Is anybody using it?
The first two questions are really beautiful. The third one, so people are creating and using their own vocabularies all the time. Whenever they create a UI with a drop-down list, they're creating a vocabulary. Whenever they are creating notes and annotating their notes with a set of keywords, they're creating a vocabulary. I'm not thinking that those vocabularies will typically compete, even if they're on the same site, will compete with ones where the 18 different definitions are created by the same entity. But it is, so the first premise is, if they do keep their vocabularies there, it is possible then to see which ones are more mature and so on and so forth, and winnow down and relate them to each other. But those people who are actually going to trouble putting in there are also going to see that there are other vocabularies there, and part of the goal is to normalize and to reconcile and to do all those things. So at one level, yes, it can create that kind of stovepiping, but the principle behind it is that in the long term, you're eliminating that kind of stovepiping by making all these things relatable as opposed to hidden somewhere where they can't be found. With regard to is it used, we have some statistics we'll be showing in the training that indicate that it is definitely used, but not nearly as much as it could be. And for the most part, most of the vocabularies that people use are major vocabularies from sites that won't even necessarily let their vocabulary be put into a repository like that, which reduces the chance of connecting the vocabularies, like I was saying, and reducing stovepiping and solving the problem around. So it's a mixed bag, but it's this session is partly to determine what direction are we going. Are we actually interested in continuing to maintain things in a common place and moving this software along in order to do that, finding funding for it, etc. Or are we going to say, you know what, donate right now, and we'll go put that funding somewhere else.
The dominant vocabularies that are inaccessible because the bureaucracy that owns them is unable to polish them in ways that the community wants is a yes.
I'm going to quibble with that slightly. I agree.
I mean, I'm trying to paraphrase what you said, and I want to make sure I capture what you meant.
The human nature, as you just pointed out, at any level of organization is to solve your own problem and stop the moment it's solved. And if you have to do something special to work with that information, that solution, you create your own solution that works with your solution. And so you get the stovepipe coming out of each of the organizations for their own problem. We just heard this morning in a data governance session, 4 people speak about how they were solving the data governance problem from 4 different organizations, all of which spoke about their organizational solution. Now, partly they were set up for that, they reach asked and stuff, but none of them were including in their organizational solution the integrated concern. Just within the space science, let alone science is global and talking to other systems now. So the medical, I work a lot with the medical groups now, and US medical profession is doing a lot of this, but there's no cross cutting between that and the others. So I don't think it's just, my point was, I don't think it's just, gee, we don't really have the technology to do this. It's a little more habit and other social concerns.
All right, so we're well slower than I hoped, which is fine. I'm actually the discussion and a little longer form, I think is fitting. But let's keep moving on here.
Oh, great.
Hi, good afternoon, everyone. I'm Benita Casey. We have a session on Thursday about data integrity in visualization and analysis tools. And the co-chairs are Elizabeth Joyner and John is here too. But for today's interoperability shorts, we're going to talk about the interoperability of visualization and focusing on just the visualization and analytical tools. Next slide, please. Basically, there are different types of interoperability. Sometimes, it can be data interoperability or the process or workflow interoperability, but I'm going to focus mostly on the tools that is visualization and analytical tools interoperability. Next slide. So pretty much everyone here knows about the benefits. I'm not going to go into the details, but yeah, having a streamlined workflow really helps, to work together smoothly and be more efficient in terms of cost and the time as well. And then they can be scalable as well. Next slide. But the challenges are many. So in terms of interoperability of tools and services, there is basically lack of holistic approach. That is meaning like different tools are designed for different purposes. and there is not like consistent usability study just to say like, that, these are the different scenarios that we want to fulfill out of like, particular tools, and there is not very consistent approach in terms of like data standards, formats as well. And then there on top of like, that there is compatibility issue that is, the tools and services from different vendors sometimes do not work together. The other issue is that there are many legacy systems that the tool is dependent on, and that can be another challenge. And then like, there is another challenge of maintaining the different versions of the tools and services. And then also the resources that like, we may not have enough resources to keep up with the tools. And the last one is that I'm not really aware of. Maybe some, here in the audience, if you are aware of that, maybe we can discuss about that. I don't think there are any standards on visualization and analytical tools. So for example, like how do we, how do we visualize the data quality information through the tool? I don't think that kind of, standards are there. And then what are the requirements for any visualization tool? Like, does it meet the requirement or not? If we can be consistent throughout this, then I think that would really help in the interoperability of the tools and services. Next slide. And there are some of the leading practices. I'm sure pretty much everybody here knows about it. Mostly like adopting open science standards, using open softwares, open sourcing the tool really helps. And in our session, like we welcome, we want to hear from the speakers because we have speakers that can talk about how they are handling the data integrity in terms of like metadata, documentation, how are these, showcasing or the visualizing the quality flags and all that information through their tool. So that we will discuss on Thursday. And then I think there should be a, we should promote the culture of collaboration that we have, and we already discussed about fair and care principles and practices, which will really help. And this is the QR code for our session on Thursday. It's going to be at from 8:30 to 10. I don't remember the name of the room, but here is the QR code. So take a look at it and please join us, and we'll have that discussion about the tools and services. That's it.
Any questions or discussion on that one? Near and dear to my heart, especially for data sets that are too big to visualize in one go. We're in the midst. I'll offer one thing. We're in the midst of a transition for data, visualizing data that's cloud optimized is a whole new ballgame, and some of the old standbys like Panoply or Worldview are struggling to keep up with the technical evolution. I think that's something to be keenly aware of as we, a sage, a very wise man named John Carone, who wrote NetCDF Java, once told me, if you're not visualizing your data, you're doing it wrong. And I think we really run the risk with cloud optimized formats if we don't have readily available visualization tools that are interoperable with all of our data.
Are they struggling because of the format, or
the technical evolution is outstripping the team's ability to keep up with maintenance of the software, essentially. Yeah, it's just the architectural changes are drastic. So yeah, cool. Thank you.
Thanks.
Next we have. Oh, I was gonna go next. All right, unless somebody else wants to go next. It's all down there. Yeah, sure. All right, so I have actually kind of adjacent to what Brandon was talking about. He and I have run in similar circles in the past, but using a little bit different lens. What I have is here. is a bit of a commentary on a transition that's going on right now in landscape modeling. Environmental modeling, especially for things like civil engineering, tends to be local, hyperlocal in many cases. And when you work hyperlocal, the data integration problem, the interoperability problem, is very different than when you're working across regions, potentially nationally or even globally. And what we're finding, so I'm a research engineer with US Geological Survey, building national applications of streamflow modeling. And what we're finding is there's an awful lot of data that's just inaccessible because it hasn't been implemented with use cases at scale in mind. And the data systems, structures of the data sets, the interoperability arrangements for the use in different software libraries, they're just not there for cases where we need to be able to reuse, you know, hundreds of data sets potentially in the same context. And so what we've been working toward is these kind of integrate everything together into an interoperability layer and then reprocess that out into something that's application specific. So this is kind of our architectural framework for the workflows that we build. Everything at the top here is what we call the reference layer. We have network attributes, so this is how the rivers connect to each other, how water bodies flow one to the next. Reference catchments, this is how does the landscape relate to water bodies. Reference flow lines, essentially the cross-reference layer of the linear representation of flows across the landscape. And this community POIs is just this huge set of things that people connect to hydrology. And I think this reference layer is not unique to hydrology. I think there's something here that's more kind of across the board, different disciplines, different sectors of the economy have their kind of reference system that we need to build. And it can't just be in the Google Index. It has to be something that we recognize as an earth science information community and curate for use in all kinds of different applications in an interoperable way. And so this layer then is used in kind of, we tried to not to make this a top up. It's not just foundational. This is a thing we build that then provides input down into a cascade of increasingly specific applications. And down at the bottom here is USGS's daily hydrologic model for estimating stream flow and water availability on a daily basis, and the National Weather Service's next-gen national water model for predicting 1 to 2 week out flood forecasts for the country, right? And so, but that's all built on this thing at the top that's assembled for parts that folks in this room might contribute to, right? And it basically we're trying to build this bridge. And then it's built off of something that came out of a bunch of work that was done in ESIP and the Open Geospatial Consortium around environmental linked features. And we've been inspired and learned from all kinds of people in the community to get here. And essentially what we have now is a set of persistent URIs minted in the geoconnects.us space that 303 redirect in the way that Tim Berners-Lee envisioned years ago to structured data and web resources that document these real world features. So the real world features are identified using URLs that don't have an inherent representation. The representation is what we redirect to and is a document that gives you metadata about that real world entity. And this is this geoconnects.us system is the only example that I'm aware of that's really trying to scale up this 303 redirect pattern, non-information resources in the real world being identified as URIs, then redirecting to structured data that documents that stuff in a persistent way, or in an accreting, growing way is the goal. And finally, this community-centered design concept is super duper central to what we're doing. There's no way we can do this without recognition that publishers have a relationship to the user community through groups that index the content, and the guidance that we share among these three groups is what we're doing here, right? It's the deliberations that a group like this have to develop this authoring guidance that provides the interoperability layer for systems like this that allow us to build out at scale applications like this. So this is just my personal work, and I wanted to share a little bit of kind of where this is at. This is flown under the Internet of Water banner, the geoconnects.us system here in the US, and it's something that we're excited to engage with folks nationally and internationally with as we go forward. And I certainly hope we continue representing this with ESA. So that was my quickie. And I think we have 2 more. Yeah.
So how often do you update your database?
So that system, the geoconnects.us system, is premised on a system of crawlers that so here. This system of persistent IDs are navigated essentially by crawlers in the way that Google navigates web links, right? And we rebuild an index based on the content that's available on a rolling basis. So it kind of becomes a live knowledge graph that's been, it's modeled on the search engine pattern, essentially.
Just curious if you're running into difficulties with carving up the real world features in a way that everybody agrees on.
Yes.
Right. That's what I think is the difficult thing about this. We don't agree about how we should represent. I mean, we do radiation budget at our.
It's endless. I mean, that's
a really tricky one. Actually.
I will quote some people that Brandon knows from Australia and New Zealand and say that we have to be pragmatic epistemologists.
That was well, everything was fine until the ontologist got
which is actually saying the same thing differently, but okay.
Here, let's
No, it really is a key. We have to take an engineer's mindset to that problem. And I've done a lot of work in that space around watersheds and rivers. There's other people that have done work in that space. Boyd Broderick around what is an aquifer, what is a container, what is contained, what is a water body, these kinds of ontological things. But we have to be pragmatic, and there's a place where we have to stop. And that's a whole.
There's that, but it's also like I've looked at that Envo ontology, and it's clearly created by Germans, right? Because it's got yeah, these concepts are ginormous, right? Things that they're like really complex concepts.
Yeah.
And so, I would not carve the world up that way, right? My features, my real world features would be much smaller than what they've got. And that is why I think, John Graviel here has takers for his community ontology.
So
right?
We could talk.
I can carve the world up that way. I have words that map onto the world in that way, right?
I have some very strong feelings about this, and this I did not write this sentence. My colleague Mike Johnson did, but I think it's really profound for science. It's not just hydrology. This idea that we study things that have really intuitive properties, and are basic landscape properties in many cases, that it's resulted in this kind of this general vagueness about hydrologic features is one example. Any number of environmental phenomena. There's a general vagueness in how we describe, reference, and understand environmental phenomena. And I think it's a fundamental problem for environmental science. I think it's something we have to solve in the literature, essentially.
Yeah, I am in favor of this approach. I just wondered if you had some really
I don't think it's
a solution that we had not.
I think we need to hash these things out and get to the bottom of them.
Not trying to be negative Nelly about it. I think that's what we should.
That's a good thing to point out for sure.
This is actually one of the reasons why we talk about in other sessions. We talk about like data quality indicators, right? We talk about like observations and stuff, like primary values, because are really important to have a good quality data layer, right? Because you have a lot of the information that we're interested in, at least historically, is just inherently like categorical, whereas a genetic naming convention, right, that you are indoctrinated to. Right. I don't mean that in the pejorative. Everybody, you need to learn how to do the thing, right? It's implicit. I'm a recovering geologist, right? You go out to the field and you learn how to see the world, or you learn how to interpret fit. So if you're in, as long as you're in that world, everything's fine. It's when you jump worlds, jump contexts, or jump space, or jump scale, right? And that's when you lose, we potentially have the potential to space. The bit that's holding it together, right? But if you can build it on the observation,
On
or
primitives,
on the
on primitives, because I think what happens is that we start arguing about whether it's, long wave radiated flux at the top of the atmosphere or at the Earth's surface, and which one which one is which, or we have to have different words for those, and instead of putting together, I mean, I know even recognizing the primitives is problematic, but I do think we have to focus more on what the primitives are, right? What are the modifiers, and what are the properties, and what are the property bearers, and not try to cram them all together into single concepts that get names.
More than yes, and more than that, I think we need to we need to push harder on the broader literature in the science domains to recognize the vagueness in their terminology.
Yes.
Which is really hard.
Yes.
Getting people
very resistant.
I've had some wild conversations of like, but you don't mean the same thing that person doesn't. And they're like, well, why is that a problem?
Yeah. I mean,
right.
Anecdote from seeing Mike McCann in the audience reminds me of 20 years ago when I was at Mbari, where Mike was at the time, and we started the MMI in part because of this problem of there not being common vocabularies across, and there were no vocabularies publicly listed that way for marine data. But when we held a workshop, the groups that had a relatively advanced and stable literature, they could like figure out, oh yeah, we've got this and that, and they could map it all together. The groups that everyone had their own model of the undersea benthos and how it should be classified, they just had no's all across purposes. They could not create a mapping at all.
All right, so we could go on and on and on, but let's keep moving. John, yeah.
Hello everyone, my name is Zhong Liu from NASA Justice. So today's title is the role of information quality in interoperability. So first, I would like to acknowledge my co-authors of the ECIP information quality cluster for putting together this presentation, and one of the authors is audience, in case you have questions. So next slide, please. So what's the ECIP information quality cluster? The cluster is to provide resources of information and guidance to data providers regarding how to implement data quality standards and best practices. So the goals are to bring people from different disciplines together to assess information quality, to establish a baseline of standards and the best practices, and to build a framework for earth sciences such as climate change and applications. So here's additional information at the bottom, and also how to get involved. Next slide, please. So in this talk, there are three key questions regarding interoperability. So first, why is information quality important to enable interoperability? So the second question is which aspects of information quality are important? And the last question is what resources are available? Next slide, please. So the answer to the first question is quality of data documentation can enable understanding for use, such as summarizing the purpose and features of the data, explaining potential applicability and limitation of the data, and also describing methods such as formats, variable names, units of measures, and so on. Clarifying intellectual property rights and any conditions or restriction of use, providing a governance and interoperability of data quality information can also enable data workflow integration, such as enabling comparison among variables and providing interpretable language and common vocabulary for use across disciplines, ensuring consistent terminology for both human understandability and also machine readability. Next slide, please. So the information quality cluster defines 4 aspects of information quality: scientific quality, product quality, stewardship quality, and service quality. So all 4 aspects are important for interoperability, but data quality is one of the most important than the other 3. Yeah, last week we had an international presentation working group. We discussed a lot of data uncertainty, challenges. Yeah, so right now there's no clear conclusion yet. Next please. So these are the resources available listed below. First, the NASA has this standard coordination office, including standards and practice for data quality and also other things like interoperability. Yeah, that's a very good resources for best practice and also for standards. And the OFAIR implementation guide, and also a paper which is in review by the leader of is in the audience, and also NASA Earth science data preservation content specification. The last is the ISO standards. I think that's all I have. Yeah, by the way, our cluster session entitled Involving Information Quality for Earth Sciences, New Challenges and Alternatives will be on Friday. So you are welcome to join in. Thank you very much.
Thank you.
Any questions?
So we're really, yeah, no, so we're really struggling. So the U.S. Geological Survey where I work, we monitor stream flow for the country, and we give one number. And it's because people want one number.
Yeah, it's not just a binary bit, is it? It's a little more than that.
Well, I mean, at any given time, there's only one number that people actually want. They don't, and what we're realizing is the idea of a known data of known quality is actually more complicated.
Yeah, absolutely.
And anyways, that is a real struggle because people they actually find it objectionable sometimes to know.
I can tell you a lot of variables in a very popular tool called Giovanni. There's no uncertainty, no error information available. Yes.
And people like it that way.
Right now they complain a lot. They're asking for that. Yeah, and I also want to give an example of interoperability in Giovanni, because we have, for example, precipitation. We have a lot of measurements. Some from modeling, some from satellite, some from the ground gauge data. They're all in different units. So basically, instead of we force them to one kind of unit, we just list their original, and then we do the conversion. In case you want something, I can give you something. Yeah. So it's more like a passive. Yeah. I know it's difficult to enforce. Because PIs don't probably already stress out. They have enough unless you give them a lot of resources like user-friendly tools. Yeah. Also, in order to get the data in Giovanni, the Giovanni team has to reprocess the data because the data can be in different format, different data structure. Yeah, that's a lot of work behind. So if we can make them, we can standardize those data sets. That would be great.
That's a hand up the back.
Just wanted to respond to your comment, where you're talking about how much people don't like seeing indicators of information quality. the only way that we've ever found success with the products that we were putting out is to give people thresholding of effectively usable, unusable, which requires you to be the arbiter of what's good enough for every single use case downstream of you.
Well, that's, yes, yes, where things are falling is we can't actually talk about fitness for use for quality without the context of what the use is. And it's especially difficult because there's a lot of the data that we collect, and this isn't just the survey, lots of federal data is used in finding arbitration or litigation. And it's very important that we contextualize that application if we're going to start to put numbers on this kind of stuff. And yeah.
Well, or you have to build the infrastructure so that you have metrics about where the data is being used, what applications it's going to, what algorithms it's going to, what research it's going to do. So you can do essentially what Amazon does and go recommender engine is running for data. Say, well, if your other people that look at this data set also use Panoply and R or whatever. But you can't do that. You can't just do that. It requires feedback mechanisms.
There's some chicken situations there.
Yeah, exactly.
A question about the this list that's on screen. We're just working on this analysis for NIH, one part of NIH, and coming up with a really long list of fair recommendation type documents. But does it help? I mean, are people able to take any of these documents and say, oh great, that really helped a lot, now I could do what I needed to do?
You have some comment? I have some thoughts about that. I think some of them, have been incorporated to the data produced development guide in terms of data quality and auto interoperability. Yeah, not all of them, but some of them.
Yeah.
Short answer is yes.
Good.
Because a lot of time you have requirements and the people on the ground, they need to comply to that, but
Yes.
they don't know what they're supposed to do.
Yes.
And it's not really their job to understand everything about requirement.
Right.
On the other hand, we would like to get feedback if people are using those documents. Most of them are for NASA.
Yeah.
As you probably noticed. And they are listed for NOAA, USGS, and USGS has a great portal on the best practices and guidance and things like that. So for the fair implementation guide, we just put it out when we were developing it. We already have people from different DACs and they're looking at it. Then they see the practice. Most of them, we're not invented them. We're just basically looking at what the community practice, and we trying to integrate it for NASA data product. So some of this aspect they're not aware of. And for example, how do you link DOI in NetCDF file? And you can put the ID there, they also how to correctly link your DOI in your website. That machine can come in and look at it. Even if you have standards, if you don't implement them correctly, the human look at it, 1-0 dot is like, oh, that's DOI because we live in the DOI world, but machine doesn't unless you tell it this is DOI. Again, there are obviously work can be done to engage the community and make it known, and also collecting additional best practices. Since it's very evolving, especially the fairs.
Yes.
Concern, as you know.
Yeah, thank you.
Okay. Our next talks are from the back of the room if you want to. By the way.
And Dave, I've abused my power to give myself screen share if I can kick you off.
Oh, do it.
And I can steer.
Yeah. Please.
Yeah. Hi, everyone. This was an unscheduled one, but Dave mentioned that there's opportunities to soapbox, so I'm going to share the thing I'd love to talk about with ESIP. And so my name is Mike, and among several other hats, I'm an editor for the Journal of Open Source Software. And so I'm going to start off talking specifically about this journal, but then expand out with the call to action at the end. But so JOS is, as you can see up there, it's a developer-friendly open access journal for research software packages. So we are a diamond open access journal, so you do not pay to publish, you do not pay to read. We are supported by having extremely thin margins in the first place. Our estimate is that's about $5 a paper, and supported by volunteer work from the editor team. And we publish papers on research software across domains, including, as we've been talking about today, plenty of things to do with ontologies, for instance. And our objective is, as much as possible, to look from the outside like a very typical journal. So if you go to, I'm picking a paper entirely at random, when you go to any of these papers, you'll see that you get the nicely rendered PDF. It has a DOI, which is registered with Crossref, all the nice things. We have the alt metrics for any given paper. But from the developer side, it's a very different process that we practice, where our reviews take place entirely on GitHub. It's an interactive process where the reviewers are interacting with the author, and you are collaboratively working to improve the software. And we are reviewing the software as well as the papers that are being published. So we ask our reviewers to actually download the software, install it, run the tests, make sure everything works, and give feedback on the programming itself. And as a result, we wind up having a lot of these papers on really useful tools across domains. Now, JOS has been around since 2016 and has been a generally successful journal. Some of the folks would kill me if they knew I was showing this because they want to be a non-bibliometric focused journal. But since 2016, we published over 25,000 papers. Our citations per document, again, they would hate me if they knew I was sharing this, is a little over 6 citations per document averaged out. Of course, dragged up by some of our whales, like the Tidyverse paper, which has been cited almost 11,000 times. But it's been a very successful experiment so far, and a way to try and get people to be able to claim credit in the sense that we're used to claiming credit as academics, as researchers, for software development activities that help underpin so much of our research activity. And so I want specifically to talk about JOS here for 2 reasons, with 2 specific calls to action. The first specific call to action is that I personally edit papers on our data science track and our earth science track, and I'm always looking for new reviewers. And so if you are interested, we have a reviewer database. It's the 3rd link in this document, and you can add yourself as a reviewer to the database here. And I will happily ask you to check out papers that get submitted. But my bigger call to action is that I think it's really important that we think about, as we ask people to do things in open, interoperable ways, think about how we give people credit for the extra work that that involves, especially in the space where we ask people to do things like develop open source software and use things in open, reproducible ways. A lot of the time, we ask people to take on that work without recognizing it in any real way. So JOS is really exciting to me because it's a way to sort of retrofit that onto existing credit mechanisms. It's a way to let people get citation credit for the work that they're doing to do things in the new paradigm. But I think that we can't only rely on retrofitting, and we need to think about how we recognize these as parts of job descriptions going forward, and how we make this something that is valued in its own merit, and not just because we can turn it into a paper that follows the traditional rails. So those are my calls to action. Thanks.
This is cool, right? JOS is awesome. My question, so to me, this is just, so my biased opinion is that this is just what science should look like. Like take the software engineering out. I mean, like big jump, right? And so my question is there, do you know any journals that are experimenting with, that are using this, that is for development packages? And the follow-up that is, do you accept, like how loose are you on software like by submitting a public paper with the data, with the package, but with the data payload, but maybe light up with Python?
So JOS specifically is looking for software, and we are reviewing software as the unit. So part of our requirements, for instance, is that like the thing you're submitting is packaged according to community standards. So if it's a Python thing, it needs to be pip installable. If it's an R package, it needs to be, it doesn't need to be on-prem, but it needs to be something that could be, so on. As far as other journals, JOS and a lot of the sort of tech-oriented journals, I think, are sort of leading the charge. So we're following in footsteps of like the Journal of Machine Learning Research. But there's starting to be more and more of this type of journal across fields. One that's extremely exciting to me that I can think of off the top of my head is, this guy could be Bon Jovi, isn't it? Journal of Visualization Research, which is still a very technical field. Nope, visualized experiments. Answering question, typing at the same time is a mistake. Research. Jovi. But so we're starting to see more and more journals that are copying this, supported by, sometimes it's MIT, sometimes it's, I think Jovi is effectively running their own system. It is complicated. Our estimate for JOS is that setting the journal up initially was about a $50,000 investment by the editor-in-chief and a few collaborators, just donating the labor to actually build systems that we rely on now. But after that initial investment, it's possible to do this in a very efficient way. And there's becoming more and more organizations that will support you, that have done that investment and can basically just cut you off a piece of their system. So I don't know any that are targeted specifically for the ontology side of things, but I can say that this ball has been pushed off the hill and is starting to really accumulate momentum.
Cool, thank you.
I'll get back to Dave.
I like giving people soapboxes because they usually have interesting things to say. Yeah, I'll come grab. Let's actually there's a mic here. Maybe there we go. Okay. Whoa, Ruth. Ruth, not Ruth, is on our screen. So I can't. So we had a good conversation among a few people in the room, which hopefully those of you who didn't pipe up found halfway interesting. For those of you who haven't piped up yet, I am really curious what you're hearing or what you're not hearing that you think an ESIP, information technology and interoperability committee, it's a standing committee of ESIP that I've been kind of helping run for a while now. I'm curious, based on what you just heard, or what was missing from this conversation, what should a interoperability committee be doing to bring people closer together and foster better interoperability?
I'll raise my hand, Dave.
Yeah.
Sorry. So I would say, what falls in your purview? Is it coming up with dictionaries and saying this is what these 5 agencies or groups are going to use consistently? Is that something in your purview? I think the one with the thresholds that got brought up later on is fascinating. As a USGS person, we used to use ratings on our data. We stopped publishing them. We say, hey, you want access to them, call the Water Science Center. And for our Water Science Center, no one has ever called us. So that, like, if you start putting uncertainty and quality on your data, what is that quality? How are we as multiple agencies and groups going to have consistency, quality, and what are we going to use? And how is that going to inform the users, and do they want to move forward?
So you think, so would a venue for discussion of cross-organizational data quality interoperability, I guess, is that kind of what you're?
Yeah, I think that would be a really good discussion to have.
Something
and have people bring examples on what their users want, right? And I think your academia users might have a different idea what they would use versus your normal person, general public.
I like that, yeah.
So can I just respond? I worry because I don't think we have interoperability at NASA, for example. Our data, our tools aren't interoperable. And if the next step is to try to interoperate with NOAA or USGS, and we're not even interoperating with ourselves, I don't know. I mean, I'm all for having those conversations because I do think we need to converge on a strategy for getting to interoperability. But I think that I'm not sure that people all even agree on what interoperability is. And so I would love to start at a really basic level and say, what are we trying to do here? Because when I talk about interoperable, I want automation. I want to push a button and, I'm going to talk to my machine and say, oh, I need this, this, and the other thing. And would you please serve it to me, on this silver platter with a side of toast? And, how do we get there? And I don't think we agree on that. And so I feel a little bit like, especially interoperability, some of us think semantics, some of us think something else, and some of us think something else, and we're all off in our interoperability silos. And maybe if we stop for a minute to say, what's the first thing we need to do to get toward, my vision of really automated interoperability, where I can analyze 5 different data sets from 5 different agencies, without tearing my hair and, all the things that, without let alone, just finding them, right? Finding those 5 data sets that I might want to analyze or something is hard enough. Actually doing all the work that needs to be done to make them work together in some piece of software that I want to use is another thing, but what's the first thing? And I don't even know if we're doing that. So I'd like to talk about that. What's the first thing that has to be done?
So I'm hearing you want to have like a definition party on interoperability.
What are we trying to do? What would success look like?
And going back and maybe having a group paper on what does that mean?
What would any success look like? Because I don't even think, I just don't even know if we're making progress or not, because I'm not sure where we're trying to be.
No, we're not interoperable. In fact, it's a holy grail. Maybe you never get there, but you strive to.
Yeah.
But one area that I've struggled with in my 20+ years, data format, of course.
Yeah.
Right, foundation, I think.
Yeah.
And about the time that we seem to be all settling into NetCDF, various flavors of NetCDF, this thing called the cloud.
Yes.
So if you're asking what we might like to see a committee or a group look at, it just not understanding what cloud friendly data formats are, well, even what cloud data formats are out there, let alone, because no one ever picks the data format. There's a threshold like there is with social media. At some point, everybody realizes that everyone else is using this data format, so I better too.
Right. Right.
So just the first step is to identify SAR and everything else that's out there.
Right.
I don't think you can pick it, but you can identify that and what's up and coming. So this is not probably going to be settled for another decade.
I am okay. So there's standard operating procedures, there's ISO standards, and there's the things we all do.
Yeah. And all the things you just know how to do that.
Well, and it's because what everybody else does.
Yeah.
Right. And I'm especially fascinated by those kind of like mass adoption events that we've seen where like some piece of software ages out and everybody finds something else and they happen to all land on the same thing.
It's not always the best thing either.
Oh no, it's not no.
The best thing.
I'll hold yeah.
So I have a suggestion.
Yeah, please.
Yeah. Is that possible? ESEP can be like a test bed for standard and best practices. you know, so we can demonstrate the power of like a fair, open science, you know, things like that, you know. So I know, you know, it's very hard for one agency to do that, you know, yeah. It's like an open platform.
And ESIP has the
Yeah.
lab, ESIP.
Yeah, that can be a.
I mean, to a degree,
Yeah.
to a degree, ESIP does that. I mean, that is ESIP, right? To not literally, but I guess where you're going with that is more could we be more intentional?
Right. Yeah, I mean the coding part, you know, the platform part, you know, yeah. Other than just a committee, you know, come up with a recommendation, depend on other people to execute. I think it's very difficult.
So like you're saying, could we as a committee identify ideas for experiments or test bed type activities?
Yeah, sure. Platform, you know, all the times. Yeah.
Like that, yeah.
I want to bring another challenge back to the next CDF. When I started with the FAIR principle, I thought that was good enough. When we're looking into what does interoperable mean, what does that entail, then we realize next CDF is really just semantic. So there are different types, the key elements of interoperability. And next CDF actually is lacking of semantic representation.
Yes, indeed it is.
So it was like, oh my God, you know, when I started, it was like, you know, we're done with interoperability as far as data format is concerned. So that could be something, because that would be helpful for the community, especially for the ones who already start using or have been using NetCDF. If we can add that layer, we can claim, at least for earth science, our data is interoperable.
Yeah, there's been a proposal out there for a NetCDF LD for the better part of a decade now. But the complexity required to adopt it is impenetrable. And
why not just turn to external metadata records? I mean,
well, right, no, and my extended comment there is I think there's something to be said for adoptability and the kind of how far do you take interoperability, because in some senses we can't adopt things that become too hard.
Yeah.
So
I think that Peng said something really important just a minute ago, though, which is there are lots of ways of being interoperable, and we often talk blah blah blah, and we're we're not focusing on the different things that have to happen. There's this sort of format, there's the semantic issue, right? You can all have the same, you can all be using NetCDF and still not be interoperable. And so, you know, maybe teasing apart the different types of interoperability that need to be tackled would be a good starting point to just say,
there's a literature on that.
Yeah. Well, everybody can kind of tackle that in a little way. Like,
so are we talking about CF convention? You know,
I'm not talking about CF conventions, though, because they haven't also not solved the problem. Because I mean, this is the question I asked John earlier, right? I have 150 different vocabularies, and I've carved the world up in multiple. CF has done the same thing. We've just carved. I come in and I go, well, it's aerosol optical depth, yeah, but I'm looking at it with a laser at blah 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 millimeters, and so I need a new word, right? And this is why why we're not solving the semantic problem either.
It's the Roy Lowry 30 axis.
Yes, and then you create, a million vocabulary words, and nobody's going to go look now once it gets past about 10, right? Nobody is willing to go search through them for the exact term that they need, and I that's a problem that we have to figure out somehow. So, I know poor Bhaskar has been.
Go ahead. I captured something on that. But go ahead.
Hi. Thanks, Ben. My name is Bhaskar. I'm Chandran, Landsat got it. You're a student of geographic information science or geographic information systems. there's a history of interoperability that goes back 50 years. But in the context of NASA Earth Science, the last 15, 20 years or so now, I've noticed, you've got these, there's a ESG/SWG group on data set interoperability, and I'm involved with PENG's group on FAIR interoperability. Just taking FAIR as an example, what a lot of people don't realize is FAIR 2 and 3, essentially call for semantic interoperability to be in existence, which is a pretty tall order. So, echoing what Beth said, we are not sure everybody's on the same page as far as understanding what these different incarnations of interoperability entail. So until and unless we are sort of clear on that, and that's where I really marvel at everything that comes from NIH, the biomedical and sciences group itself. Yes, we really have to be able to first decide what do we mean by interoperability. And for the most part, we are talking about, at least in FAIR, interoperability, you're driven towards a capability towards enhancing the semantics of the data, but unfortunately, we are not there yet.
Don't get too excited about NIH's interoperability. Well, but there are some good things there.
All right, I really appreciate the conversation. Anybody else? I've captured a few ideas to pass on to Chris. I'll sort of maybe see this.
Like, has anyone ever worked with data.gov? Because that's the place where all the federal agencies data, right? So
yes.
Everybody's. You got a few people in the room who certainly work very closely and have a lot of feelings about it. Well, I mean, that's an example of a highly underfunded endeavor to bring something really big together, and they did a lot, but it does leave a lot to desired. And I think conversations like this could help see changes culturally that would allow things like that are actually very small from a dollar investment point of view be much bigger than what they're now. So we got.
Yeah, so I'll just add one more thing and maybe contradict myself in a way. So grounding in trust, data ethics, and empower collaboration. The conversation in here is about Earth Sciences data, and specifically about Earth Sciences data formats. There was a discussion earlier about what do our users want. A few years back in the Weather Service, we started to try to take the data out of the meteorological unique formats via all the different formats that we had that were difficult and expensive for somebody to access and understand and get to use, and started to put them back in those days as XML, which is then today, of course, is JSON. And you know what? When the Hurricane Center, for example, started to put the code of in XML format in products, all of a sudden we started to see that code everywhere. And that was a wonderful thing for us because we could not afford to run a website where the code that was the only place where you could get the code of death. We didn't have the budget to run. It was too expensive. And not to mention that once anybody, basically any college kid with a library could access it and display it on a map someplace, it suddenly got out into a lot more places and got to be seen by a lot more people. So that's another thing to keep in mind, that break the barrier, go outside of these proprietary formats, especially if you want to talk about dissemination and how to translate them into, sort of goes back to my comment about cloud-ready formats, because they tend not to be, from what I've seen, some of them tend not to be centered toward one type of science.
Sorry, I have to go, but I wanted to say, is that right?
Yeah,
Or did you-
please, we're pretty much at time.
Oh,
So,
yeah.
but yeah, throw a last word.
Right, the quick one is, it's slightly tangential. But I was, within the context of the IT and I initially, but, we used to have like one day events before you said, right? Like, what like an IT and I forum, like bring your code standard interoperability thing and we'll hack it, right? When you think about the skills in the room, what can you do in a day to address some of the shortcomings, whatever it is you decide, right? I mean, like Joss, you know, so have some submissions.
Yeah.
I don't know, might be too much time. Don't be like time for it, but it's interesting to see what you can do in a day.
Yeah. Yeah, this idea of the test, but I've never been able to identify a good thing the committee could organize that was more than getting together and sharing ideas. Sure. Right. And I think like a test bed or an experiment or some kind of focused I don't know what to call it a hackathon, but a forum. I like that's a good word for it.
Talks are built to go through those. Sorry, I gotta go.
All right. Well, we're at time. Thank you so much, everybody. We did justice to a session that I wasn't quite sure was going to be. And thank you for coming along on the online, everybody. I'm sorry we weren't more inclusive, but I was trying to get everybody in the room to talk as much as anything. So did okay. Thanks for coming, everybody. I will go track down the incoming IT and I chair and convey as much of this as I can. Is that you? You're here now. Cool. All right. Well, at least you got the end of this. Let's catch up. Yeah. Thanks for coming, everybody.